Here we have the function 3x squared plus 3x minus 5, and we want to find the intervals on which the function is increasing or decreasing. And when we're talking about increasing or decreasing intervals, we will go from left to right. And so let's say we start here, and we go from here to about right here. This graph is going down. And so we say that the graph is decreasing from the left side up to this point, up to this value right here. And then from here to here, the graph is going up. So we say that the graph is increasing. And so first we need to find what this value is. But this value is at this minimum point right here. And so to find this value, we need to find the critical numbers. And then that would tell us what this point is, and then we can figure out the intervals of increasing and decreasing. And so first, let's find the derivative. And so the derivative of 3x squared would be 3 times derivative of x squared is 2x, and then the derivative of 3x is 3, and derivative of the constant phi is 0. And so we get 6x plus 3. And then to find critical numbers, we set the derivative equal to 0 and solve for x. And so we want to solve this equation right here for x. So first subtract 3 from both sides. Both sides we get 6x equal to negative 3. And then divide by 6, divide both sides by 6, we get x to be negative 3 dividing by 6, which is negative 1 half. And so this value right here is x equal to negative 1 half. And so to find this point right here, we need to evaluate the function at negative 1 half. So in the place of x, we put negative 1 half. And then to simplify all of this on a scientific calculator, then we get negative 5.75. And so f of x, the function here, has a minimum at the point negative 1 half and negative 5.75. And so that's what this point right here is. And so the graph, we say that from the left side up to negative 1 half, the graph is going down. From left to right, the graph is going down. And then from negative 1 half to positive infinity, the graph is going up. So from negative infinity to x equal to negative 1 half, graph decreases. And then from x equal to 1 half, negative 1 half, to positive infinity, graph increases. And so this is how we would describe it. We say that f of x decreases on the interval from negative infinity to 1 half. negative 1 half. And then we say that f of x increases on the interval from negative 1 half to positive infinity. And then evaluated it, then the first derivative would be positive. So for example, like for this interval right here from negative infinity to negative 1 half, let's say we picked negative 1, and then now we evaluate the derivative at negative 1, then we get negative 3. And so for any number in this interval, the derivative will be negative. And then if we pick any number from this interval, like let's say we pick 1, then the derivative will be positive. So here we get a 1 and we get a 9. So this is less than 0 and this is greater than 0. So once again, if we pick any number on the interval in which the function decreases, and then evaluate the derivative at that value, then we get a negative number. And if we pick something from the interval in which the function increases, then use the derivative to evaluate that number, then we get a something that's positive. Now let's look at the graph of this function, and then look at the graph of the derivative function, and then we will also see this. Again, the blue graph here, that's the graph of the function f of x, 3x squared plus 3x minus 5. And then the red one, that's the derivative function. This is the graph for y equal to 6x plus 3. And notice that the critical number is at negative 1 half. And so the red line at negative 1 half is below the red one. This graph right here is below the x-axis at negative 1 half. And then it's above the x-axis from here to here. So the derivative from negative infinity to negative 1 half is below the x-axis, and then from negative 1 half to positive infinity, the graph of the derivative is above the x-axis. And so that's another way to look at this. And so if we pick any number between negative infinity and negative 1, then we're going to get a negative value for the derivative. And from the graph, we see that it's below the x-axis, and then from here on it's above the x-axis.